All right, welcome back. We are COMP2142. That's Game AI 1 in the winter 2026 semester at Georgian, and it is week 4, part 2 of our broadcast and recording. In the last recording last broadcast, we talked about assignment 1B, which is going to be due on week 6, right? So again, going back to our schedule, it's not that far off from midterm tests. People have been asking what it's going to be on for each of them. They're all practical, all 3 tests, just to say that again. I know people asked yesterday. Logan was one that asked. So I think it's the same thing for these ones. Well, you'll be asked to do something that is doable given the material that you've been shown in class. So it's going to be using something that we've been using the entire time, which is our project from class. So again, it's really important that you follow along and practice and everything else. I can't stress that enough, so that you're comfortable with the material, so that you're not like caught flat-footed, like I said, during the exam. Because it's like, hey, how does this all link together? Well, I've never looked at this before because my partner's dealing with it, and I'm working on one course and they're working on another course. Guys, that's not a good strategy for what's going to happen on the midterm test. You need to know how to do things on your own. Okay. All right, so let's get into it today. So I want to talk about sensing first, and we've talked about this already, but I want to discuss this in terms of one of the main things that when it comes to detection. We're starting to talk about new steering behaviors today, which is obstacle avoidance. And one of the things that we use a lot of times is this idea of a field of view or line of sight, right? So we use this line of sight mechanism for enemy detection. That's what we do, right? And typically we have some kind of angle. Now it depends on the game you're playing. If you're playing a game where it's a top-down game and you're using a hexagon grid or something like that, because each hexagon is 60 degrees, as an example, each side of the hexagon, there's 6 sides. 6 times 6 is 36, that's 360 degrees. Then sometimes what we use in that case, if you're using some kind of hexagon grid, is every facing is 60 degrees. That's your line of sight. That's your field of view, let's say. But it could vary if you're playing a top-down kind of game, or if you're playing a first-person perspective game, your field of view could be like 108 degrees, which is some people play with that when they're playing competitive games, or even greater than that, right? So that's your field of view. But how does it work when it comes to an AI, right? Well, there's 2 parts to field of view and line of sight. One part is the range, how wide you can see it. And I think about this a lot of times as a cone. We've seen that example last semester when we put the perception system on our enemy. We did that, right? But also the distance. That's also another thing. How far can the enemy see you? And it doesn't matter which game you play, how complex the game is. The enemy will see you. And if there's 2 parts to it. Okay, I've detected you. Yes, I can see you. And the next part is, are you close enough? Are you within, my little patrol area, right? And if you're within my patrol area, we're going to fight, or I'm going to call the guards or whatever, right? And that's how typically it works for field of view. We use those kind of things. So again, we can make these, you can use raycasting or spatial queries to detect obstacles or things in your field of view, and things that are outside your field of view, even if you might be able to see them in real life, are not spotted, or things that you're ignoring. Sensing radius is the other one. So if I was going to make a game from scratch, let's say next semester, if some of you are going to Connor's game engine architecture course, like if you go to 3rd year. Then what he might be basing it, baking everything in, you are going to make your own AI system. You're going to make your own collision-based system, your own raycasting, all that stuff is going to be on your own. So a nice way of doing things is using something called the sensing radius, and we've done this before, right? So, so sensing radius to me is, it is usually used for hearing or smell, some kind of proximity-based detection. So maybe it's a trigger. Even if you're sneaking in somewhere, if you go into that room, you're going to be detected. Maybe there's cameras or something or whatever. So there's different kinds of checks that you can make. One of them is passive. So I've heard some footsteps or active, where I'm periodically scanning the area. All right, so those are two types of sensing you can use. You can adjust the radius for realism. We can increase the larger radius for loud noises like explosions, like a grenade, and smaller radius for things like sneaking and whispering, right? So it's kind of cool. Excuse me, how this can all work. And I think combined with line of sight, you can make your own sensing system, right? Unreal uses this sensing system. We've seen it last semester, where we can put a sensing system on an enemy like this. This is the enemy that we were using last semester. It uses a built-in perception system, and the way it works is when you use the perception system, you can decide what sense types are supported: sight, hearing, whatever you want, right? And when you do this, there's two pieces to it. One of them is, these are the things that I can use to detect, and the other one is some kind of emitter. So for notice here, we have a pawn noise emitter. Well, so any pawn or character that you want to be able to detect, you have to have this second component on them, right? So for example, I'm going to, they can see me, as an example. So there's two parts to it. If you want to be detected, then you have to have a special component on your pawn, on your character, right? For different kinds of things, whether it's noise or whether it's sensing or whatever, or sight or whatever. Okay, so that's how it works. And then, like we saw last semester, we had this idea of on-see pawn. So if you haven't had a chance to take a look at that, or if you weren't part of our course last semester, these are the things that we can use that are built into Unreal Engine that we can see things with. Funny enough, if we wanted to build these in to use obstacle avoidance, we could do it too, right? Because it's built in. So because we're using a three-dimensional view, we could do a lot of the stuff that we're doing here manually with this. The problem is, if we're going to use this sensing system, we need to get a bead on how are we colliding? And that's why we're going to talk about this idea of whiskers, because you need to understand where, like, you're overlapping, right? It's different if you have a cone. Okay, I'm overlapping. Or a sensing radius, I'm overlapping. But where am I overlapping? Is it on the right side? Is it on the left side? Is it in front of me? Is it behind me? Where? And I think that's the trick when it comes to this stuff. And that's why we talk about all this stuff manually, so you can enhance what we've talked about here with our algorithms. So one thing we're talking about today is we're talking about arrive, flee, and seek. I've asked you guys to do flee last week, so hopefully you guys did it. And we're able to do that. And of course, flee and arrive are all due on next Tuesday, to make it all work. I'm going to show you an approach to arrive and flee, but you might do it differently. All right, so one thing about arrive is, and I talked about this last time, is there's kinematic arrive and then there's dynamic arrive. And the way you can do it with dynamic arrive is if you have an arrival radius, right, which is and then there's a second radius that's much larger, that is like your slowing radius. So your slowing radius is out here and your arrival radius is close in, okay? And that's kind of something that you can do, so that way when you're within the arrival radius, you stop, okay? Because that's what the behavior is supposed to be. And I'm going to show you some parts of the behavior today. It's not complete, but you're going to see that there's another step you need to take. I'm going to give you part of the entire algorithm, but some of it you need to tweak a little bit, okay? But what we want to talk about for assignment 1B is not collision avoidance, but actually obstacle avoidance. So collision avoidance is interesting because collision avoidance talks about when there are two objects that are moving. So imagine if I have two AI agents and they're moving and they're going to collide. So they kind of have this future prediction of when it's going to happen, right? So what we might want to use is this idea of an evasion. Okay, so if I'm going to collide, I want to evade. I'm not going to flee, because that doesn't make any sense. I'm going to go away from where you could flee, but you want to kind of move away or steer away from where you're going, and then steer back to your original goal, all right, so that you can avoid things. The challenge is if you're heading on, like if it's a head-on collision. This is kind of an interesting collision because in the future, both of them are going to collide, right? But what if it's head-on? And the problem with that is you've got to really look forward, and if you know which way you're going to turn, what way are they going to turn? Because you can zig when they zag and still hit. Like, you know what I'm saying? Like, have you ever walk in a corridor and you're like, you know, there's a person in front of you and you kind of step to the right and they step to their left, and then now you're in front of each other again. Then you step to your left and they step to the right, and now you're in front of them again. And, you know, you're trying to avoid each other, but you keep on moving closer, and sometimes you might even collide with them because or you might stop because you're like, wait, what are you doing? You go ahead, you know, kind of thing. So that can happen too with AI, and the AI doesn't know how to stop. It doesn't know what to do, and it'll just collide a lot of times, even if you try not to have it collide. But obstacle avoidance is a little bit easier, and the reason for this is because these obstacles are fixed in place. It could be a building, it could be a pillar, it could be whatever that's in the way. And what we want to do is we want to have this idea of a steering away direction. So in this case, if you notice, we're casting in front some kind of volume. Okay, it could be a volume of like a rectangular prism that we have in front of us, or whatever. It could be that. But the idea with this volume that we're steering with is we're going to get information from the world, the game world, that's telling us which way to go. So if I'm overlapping with B, then we know we got to steer towards the left, this direction, right? But I'm also overlapping with C in the future, which means I got to steer more to the left. It's almost as if I need to have two little normals, and when I steer from here, as I come closer to C, and I'm steering away from B, and I got to keep steering away, but I don't want to steer into A, So there's almost like a desired path, and it's clearly between A and C, which is where I want to go. You can't tell the AI where to go; it's got to figure it out, right? You don't want it to go between B and C. That's weird, right? That's going to be a tight turn. And if your AI doesn't have that angular acceleration or rotation rate, if it doesn't have the amount to do that, it's going to smash into these things anyway, all right, even if you try and avoid things. Again, what I always say is, when you know you're going to collide, start slowing things down, right? When you start slowing things down, it makes it easier for your AI to avoid collisions. And the other thing that you want to do is you want to steer in that direction for a much longer period of time until you clear the collision. Then you steer back, okay? So how do you know how to do that? Well, we can use things like rate casting for this, right? So, rate casting is such an interesting word. Really, what is it? You're drawing a line and you're intersecting that line. So line and other object intersection. I'm overlapping a line and a sphere. I'm overlapping a line in a cube. I'm overlapping a line and some other shape, some other rectangular prism or whatever, right? And once I have an overlap and I know that thing is overlapping, that's what a rate cast does. You can do certain interesting things with it. You can make it bounce, right? So you can have a collision normal. You can do other things where it'll inform you that that particular line is colliding. And there's a bunch of things you can do. One thing is like, where is it colliding? Is it close? Is it far away? Like where on that line segment, as an example. So there's a bunch of different strategies on how to configure your arrays. Clearly, if you had an array like this, right, which is a single line only, that's going to be a lot easier for you to collide with than if you had multiple rays, okay? And then the other question is, how many rays are enough or too many, okay? So, because again, you're doing collision detection with all these things, and if you had these for every AI, it could be computationally expensive, right? So let's do a test here. So if I was going to, actually I don't know if I can do that from here, but if I was going to have an object, and if we were going to create one, let's just make one with Excel here, or sorry, with PowerPoint. So here's my object I'm kind of simulating, and let's give it a little bit of an arrow. So let's give it one of these arrows here. So we'll kind of define the forward direction of the object. So here's my forward direction, and I'm going to make this so it's grouped. All right, let's see if I can do that. There we go. So there's my grouped object. Let's make this one bring to front so it doesn't look as bad. There we go. All right, so this is my grouped object, and now unfortunately I don't have a pivot point that's back here. I have a pivot point that's up here, so it's not going to be very accurate. But imagine if this object was potentially colliding with another object. Let's just make it something like this, right? Okay, here's my object I'm colliding with, and let's just change the color so that way we can, have a different color. There it is. Okay, so here's my object. So if I don't have anything, I'm just going to collide into it, right? Because I mean that's just the way it works. Let's put this, bring send to back. So I'm going to collide into this thing, right? Now if I cast rays, let's cast some rays, and let's do it so that it's in front of the object. So here's my first ray. And again, what I want to do here is let's link this together with this one, and we'll group it. So there it is now. Here's my ray. So now I can detect this, and now the question is, which way do I turn? Do I turn left or do I turn right? How do I determine that? And what if there's different places to collide with. I can collide here, 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 all these places, right? So how do I know if I should turn left here or compared to if I should turn right there? The answer is you don't know. How do you know that? Unless you cast multiple rays, right? So that's a thing to do. That's why a single ray like this may not be sufficient for most use cases, right? So then that means we can add multiple rays. So let's cast multiple rays, make another one that goes this way. And again, the ray length is also important, because if you have a ray length that's too short or too long, that can also mess you up in terms of the way you move. So I've got these two things. So we're going to select this one and this part and group that one together. Now we have this. All right, so now we hit, we know we get a turn, and let's say we make an arbitrary turn to the right. So we're going to rotate to the right this frame as an example. Let's put it here. And then we progress a little bit. Oh, wait, now I've hit this thing, this ray, so we know we've gone in the right direction. I mean, it's not really the right direction, but we know there's another, we're colliding, and that's to be expected. Okay, well now we need to turn a little bit more because we want to avoid things. We turn this way, and then we go in this direction a little bit, okay? Now we've avoided stuff. Here's the trick. We don't want to turn back, okay? We don't want to turn back here, because if I turn back, we hit that again, right? And so we don't want this thing going like this all the time. We don't want that. We want it to go for a while. When we hit something, we know we have to turn in this direction. We march in this direction for a bit, all right? And then what happens is, when we're sure we're clear, and again, like some amount of frames, you have to test this out, then you start turning back towards your goal. And the way to do this is really have those two pieces. So you have your obstacle, that's your obstacle, and let's copy paste this thing. So here's your goal. Let's say your goal's over here and your obstacle over here, and let's make this so that it has a different fill. Just so that way we can, this really bothers me. Let's see if I can hide this thing. Yeah, there we go. So what I want to do is, let's go back to this, and I think if I go to shape format, and if I make this red, that's more apparent. There we go. So again, I want to avoid this, and this time, instead of turning right, I turn left. By the way, it's just arbitrary. So I keep marching forward. Oh, I'm still need to turn more. And if, depending on your turn rate, you still might hit, right? That's why you have to slow down. And then what I do is I clear this obstacle to some degree, you don't know when, and there's nothing in front of me, there's no other obstacles. Then I need to start turning back towards the direction what I want to go, frame over frame, until, and again, I'm doing this badly because of my object that I have, until I'm here. And depending on the type of other steering behavior you're doing, if you're doing seek, it's just going to keep going here and it's going to come back, it's going to turn around. If you're doing arrive, which is what we've talked about, then arrive is going to have some kind of radius that's around this thing, which is kind of like the outer radius. There's two radii. Make this so that it's like a thing that you can see. Here's the outer radius for arrive, and once I come here, that's the slowing part. I start slowing down until I stop. Yeah.
Why would you have it on the object and not the end?
Because
slowing down like this.
Because you don't know like where, I mean, and this, by the way, this may not be enough slowing down radius. It might be something like this, like where you want to start slowing down like this. But the reason why you want it here is because this is the place where you start slowing down and slowing down and slowing down. How are you going to know when you slow down? You don't know the distance. And then unless you do, you keep getting distance calculations, computations every frame, which is really computationally expensive. Because distance calculations mean I'm doing some kind of square root, or I'm doing, Pythagorean theorem. That's the distance, right? Or Euclidean distance, right? Whatever you want to call it. So it's better, it's more computationally sound to do it with a radius like this, where we hit this radius. Once I penetrate this radius, or overlap, then I know I have to slow down until I stop. And let's make this go to back. Until I stop. And when I stop, I don't want to turn. I'm not doing this. I'm not turning around and moving when I'm stopping. I'm completely stopped. That's the trick with arrive, okay? And we're going to see today that that's not what's going to happen with our little character. So I'm not giving you the entire thing. I'm giving you part of it. You need to kind of tweak it a little bit to make it work. All right, so that's this. And that's obstacle avoidance. That's what we do. So there's 3 whiskers, but there's nothing stopping us from having more information, but there's diminishing returns. Each one of these things is doing overlap detection with each one of these, which with the objects in front of it or that are overlapping. So again, if I add more whiskers, like if I do something like this, if I add a whisker here on the right, by the way, these could be valuable pieces of information, right? Like a whisker to the right, and then maybe another whisker down here to the other side. You know, or maybe that's the left, this is the right. You know, and again, depending on the whisker length. And you could have other ones where you have whiskers in between, like something that looks like this, you know, as an example, and maybe another one. Now you're talking about for each of these whiskers that you have in place, and it could look like this, right? You have collision detection and overlap testing for each of these whiskers, right? So the challenge becomes, yes, it becomes more valid because now if I go to the thing to collide and I turn and I move forward, I'm still colliding and I keep turning. Oops, I keep turning. Sorry, and I keep doing. Now I'm colliding. Okay, you got to keep turning more, right? And then I keep doing it. And I keep turning, right? Because I'm getting information that I need to turn, right? And look, there's more there. Then I'm going to keep turning until I clear it, and then when I'm out, now I'm going to start turning back. So this is where the next frame up here, I turn back, right? And then I'm going to keep going forward and turn back and keep going. Then I've got this new direction again. From here, once I clear, I can start using seek again or arrive to go to where I have to go. So there's positives and negatives about this. It'll change your behavior of your AI agent when you have this kind of thing. All right. There are other shapes we can use, like we talked about this, and notice that there's these 2 little spheres, or at the point circles at the end. You could use you know, a sphere here instead, you know, as in terms of circles, and that could be, you could have 2 overlaps here on the side as opposed to what you've done there. There's many ways that students have solved this for me in the past, not just one way. It doesn't have to be just 2 whiskers on the side here. By the way, this is also, parallel rays is also not negative. The only problem is when you get into this situation, right? Where the parallel rays didn't detect it because you're only looking forward and you're too close, you're going to collide anyway, because a single ray definitely will do that. And that's why you need a triple ray cast or something like that. This, again, might be overkill. Okay? Questions around obstacle avoidance, because I wanted to talk about the general idea behind it, because you guys are going to code this for 1B. All right. So let's add some UI to our current project. And for this going back to the new thing that we're doing, I've brought up a project which is from last week, week 3. I copied it to week 4. So here's week 4. And just to prove that it's the same thing that we had last time, if I press the 1 key, you know, kind of thing, while it's live, it'll go and do its thing. Okay. One thing that we also had for last week, I asked you guys to do flee. So an easy way to do flee, but a bad way to do flee, is to copy the exact same thing. Let me show you what I'm talking about. So if I go back to blueprints, and if I go to my grid character, here they are, right? Again, this is a project which is, so make sure that this hides again. Yeah. So if I look at my project for seek, so here's my seek algorithm, the naive approach would be to copy this entire thing over again. Okay? That's the naive approach, my friends. So we know that this right here, this area right here, is what we need to change, right? Why? Because target location minus current location creates a vector, right? And again, if I was to draw this out in the PowerPoint document, let's just go back to this little open space here. What I'm saying is, if I have my target, so let's just draw the target. So here, let's say this is the target, and let's say this is the start, and this is the goal. So we're going to make, you know, this one green, And we're going to make this one red, and that's the goal, you know, where we want to go. And I want to go from here to there, right? I need to know this direction. And from a vector calculation perspective, when I subtract from my target, subtracting my my starting point, I get a vector that looks like this. That's what I get. All right, it's a pointer that goes this way, right? And it's the entire vector length. I don't want the entire vector length. I just want the unit vector, so I need to normalize. And the unit vector looks something more like this. Okay, that's the unit vector. Okay, and then once I have this unit vector, then I'm going to march in that direction, frame over frame, and that's where I'm going to go. So now, if I want to flee, it's going to be the opposite. So that means that I'm going to take my current location, subtract it from my target location, which means I'm going to get a vector that points this way, okay, at the other direction, right? And of course, I don't want this whole vector. I want the normalized vector, which means it's going to be this, right? So kind of like a unit vector, right? So really, the only thing I'm changing for a flee, right, is this part right here, the subtraction. What am I subtracting? Am I subtracting, so target minus current, that's going to be seek. Current minus target, that's going to be flee. So if you did this whole thing again and copied all this crap, guys, that's bad. Don't do that. That's you know, inefficient, right? So how would I do that better, right? How would I do that better than what I have right now? I want to make it so that I need to have, you know, this, you know, that's what's my target and what's my current. You know, now you could change that for seek, right? Seek behavior is, you know, if I want to go the opposite direction, how do I do that? I can multiply it by -1, right? That's something I can do. And then if you were to do that, then it would just, whatever this result is, I would multiply at the end. The direction would multiply by -1, and then you're good. I mean, it's that simple. You don't have to modify the seek behavior. You just have to make it so that, are you fleeing? It could be a question, flee, yes or no. And if you're fleeing, instead of, it's a type of seek behavior, then you reverse, you kind of invert the vector, right? That's what you're doing. You're flipping the vector, right, in the opposite direction. Now be careful, because if you do it wrong, you're going to go in a weird direction. You're going to go in the Z direction or whatever. But all you care about is the X and Y, right? And whatever those values are, if you change the direction of both those values, it can be tricky. So the easiest way to do it would be to flip it somehow. But remember, you're still doing this vector subtraction here, right? I'm subtracting this one from this one. So think about how to do that. It's math, but it's not that difficult math. What I'm going to do, because I'm not going to give you the answer, because it's you to figure this out, is I'm going to copy it because it's a dumb way of doing it. But you need to figure this out. It's really dumb if you can't figure it out. I mean, I'm just being honest, but you know, I want to make a brand new function. Let's call this flee. Here's the bad way of doing it. Please don't do it this way. I would ask you to try it the nicer way. And it takes some trial and error. And I can copy this entire thing and go back to flee and then paste it in. Oh yeah, and I'm really smart if I do this, right? It's kind of a dumb algorithm. There it is. And then what I want to do, by the way, the other thing to do is this. You do all this calculation first, somewhere outside. You know, as an example, you do this calculation outside of this, and then you bring this back into like the direction, this direction, as an example, the direction of the flee or the seek. You could do it outside, and then here you'd have a direction. That's another way of doing it. Okay, so you can calculate that outside of here. Now, one thing is whenever you copy nodes like this, notice that these are all gray. It means that they're not created. So I can right-click here, and I just can create a local variable, name that. And it kind of fixes that problem. Same thing, I can create a local variable, and that fixes that problem. Same thing here, create a local variable, and then I'm good to go. Now, what I need to do is reverse this, so I'm just going to disconnect these. Dumb, this is really dumb. All right, and then do this. Now, there's a lot of duplication here, and when you see a lot of duplication, that should tell you right away something's wrong. Okay, this is it, that's flee. Right, compile and save. That's the only thing you need to do for flee. Please don't do it this way. Okay. So now that we have flee, we need to be able to activate it somehow. And I'm going to go back to my inputs. I need an input for flee. Here's my action. I'm going to add a new input. So input action, and I'll say IA_flee, right? And then I have to set that up with my mapping context. So here's my mappings. Let's add one in, and let's map to flee. And of course, the first one is a 1. Flee is, I believe, a 2, is what I asked you guys to do. There's 2. So that's flee. So save. There we go. And now that I've got it mapped, then I got to put it inside of my inside here, right? So I've got to be able to respond to flee. And we can do that because I have this toggle behavior for seek. Then all I have to do here is I just got to go IA flee. And then once I'm fleeing, I want to do it on started. And I want to take this toggle behavior, this exact same thing, copy paste, and then connect it. Here we go. And now we can change this to flee instead of seek. And then if I collapse these, it looks just like the other one. And we can just annotate this again by saying flee steering behavior. It works. It will work, right? But it's ugly as hell. All right. So please, I'm telling you this over and over again because it's just bad coding, right? It's not great. It does satisfy the requirements. I know some people are like, but Tom, you said that it's like make it work then refactor. Okay, I say that. Yeah, absolutely, right? So if you want to test it to see if it works, fine. This is good. This is a good test. Now fix it. Make it better because this is terrible. Terrible. Okay. All right. So now that we have flee, let's test it. So flee is best tested when, if we press play, I want to move my start pawn right next to my goal pawn and then press the 2 button, right? That's what I want to do. So press 2, and then it should just, flee away, right, in a direction. And it's going to keep going until it gets to the edge like this. So if I go back to here, if I move it, no matter where I move it to, you can see that as I move my pawn closer, it's just going to run away from my goal pawn in the opposite direction. Okay, that's what it's going to do, right? So it's going to keep going away. And the same thing goes with if I do one of these. So it's fleeing, and I put my goal pawn there. Then here, and then if I put my goal pawn there, it's going to keep fleeing away from my goal pawn. If I move it dynamically around the screen, it's going to keep trying to avoid my goal pawn. So in many ways, obstacle avoidance is a type of flee, isn't it? Right? You want to run away from your goal pawn. Well, you can run away from your obstacle as well. The challenge is if you have 2 behaviors, I want to run away and I want to target this another place. That's too difficult. That's why we need to use these other methodologies to do the same thing. All right, so we've tested flee and it works. Save all. I'm going to put this up on DevOps so you have a copy of what this looks like. Git add dot git commit -m. We'll say added simple flee behavior. And I mean simple as in like bad. Okay, there we go. Hopefully, you're not going to do it that way, or you haven't thought of it doing it that way. That's bad. Okay. Next, now that we have flee, I want to start building a user interface. Because I want to be able to connect things, and this is kind of one of the things I asked you to do. Please don't use my user interface that I'm going to give you. I'm going to show you. I'm going to talk about user interfaces today and a widget blueprint. Like we did before, yours should look much nicer than mine. Remember, you're getting aesthetic points for how that looks. But I want to show you basics so that we know what I would normally do for it and, some simple things. It's also a bit of a review from last semester because it's not the first time that we've done them, right? So let's do this again. So back to this. So I want to make a new HUD class. That's the first thing I want to do in this case. So again, going back to this, I want to make a brand new blueprint, and notice it says make a folder named UI in the blueprints folder. So I'm going to do that. So new folder, I'm going to call it the UI folder. Inside there, I'm going to add a brand new blueprint class, which is of type HUD. So I'm going to search for HUD down here. We've done this before. Here's HUD. There we go. Press select, and now we have a HUD. So BP underscore steering behavior HUD. That's what that is, SB HUD. And then the HUD itself is something that I want to use with my mode, my game mode. Game mode is right here, grid mode. So I'm going to double click on that and select, instead of the regular HUD, I'm going to make my own BP underscore SB HUD. That's going to be the one that it's going to instantiate upon load. Compile and save. All right, so now that I have that part, and if I go back to my UI, this is my HUD. Okay, so that's the first thing I'm doing. I'm adding a HUD. And the next thing I want to do is I want to add a widget blueprint. We've done this before too, so I'm going to add in a new, if I go down to user interface, I want to go to widget blueprint. It's going to be of type user widget, and I'm going to call this widget blueprint, WBP underscore, and it's going to be steering behavior overlay. Okay, that's what I'm making it. An overlay is the thing that I'm doing right now. It's not a health bar. It's not something else. It's an overlay, right? So if I double click on it, now this is where I'm just going to fix that problem, because I mean I'm starting off a new project. Let me just fix that. Sorry. Whenever I do this stuff, it makes me crazy. So here it is. I want to add a canvas element first, because that's where my, my widget's going to live inside my canvas. There it is, as an example. And inside my canvas now, I'm going to add in a bunch of stuff. Now, what I did here in the PowerPoint is I connected my HUD with my widget blueprint as soon as I connected it, so I don't forget. That's why I did it this way. So I want to go skip back, compile and save, skip back to my HUD for a second, and in the event graph, I'm just going to get rid of this. I'm just going to create widget of type, of class, WBP SB overlay. That's what this is, right? And then what I want to do is I want to add to viewport, which is right here. This is kind of the basic things. We've done this over and over again, and this adds the viewport for the entire HUD, okay? So that's that thing right there. So that's what's going to happen. It's going to add in my overlay. My overlay right now doesn't do anything, okay? So I don't need this. This is what I've just done, okay? Once I have that and I add in my, my canvas, I want to add in an image on the canvas, and I want to make a border, a black border around the canvas. Now there is no border tool in my widget blueprint, and the way to make a border sometimes is what I do is I make two images, one that's black and one that's a lighter color, and the black image on the background is slightly bigger than the image on the foreground. And notice that there's a couple things here. So let's do this. So back here, I'm going to go and add in an image. So I'm going to kind of go to image, just drag and drop an image in there. And this is going to be called border. The image is going to be, the position is going to be 25, 25, 650, and 400. So again, here, 25, 25, 650, and 400. That's the size of my HUD. The brush, the Z order is going to be 0, but the brush color, or the color and opacity, I'm going to make it so that it is 0, 0, 0. So it's going to be a black border, okay? That's what it's going to be. Oh, 0, 0, 0, 1. There we go. Okay, so that is, actually let's make it 0.3 so it's not completely black. 0.3, there we go. So that is my, my border, all right? And then what I want to do is I want to add another image, right, on top of that one. And this image is going to be called the background. So that's what it's going to be called, background. And that background image is going to have these numbers, 35, 35, 35, 35. And then it's going to be 630 and 380, 630, 380. And I've calculated this so it sits inside of the border. That's what it's doing. And then with the background color of 0.65. One thing also is the Z order is going to be 1, so it's going to lay on top of. We're forcing it to be on top of the background just to make sure that that's correct. These are 0.65 each, 0.65, 0.65, and 0.65. I've chosen this gray color, and then the background is 0.3 again, so it's going to be semi-transparent, so you can see through it. So that is your background. You can see that there's 2 layers here, and that's your border and your background. Next, once we've got that, we're going to add a text value called speed label. Right, so there's my speed label, and we're going to do that. So there's my text. Here it is. We're going to call that speed label, and the speed label is going to be at 56, 40, 224, and 30. Again, 56, 40, 224, and 30. There it is. And then it's going to be Z order 2, so it's going to be laying on top of my background, and the text is going to show speed. So there this is. And I want to use this, which is kind of a line right, which is going to look like that. So that's going to be the first one. Next, I want to add in another one. And what we can do here is we can just simply duplicate this one because we have the style and some values. But we want to change 56 and 96 to where it's going to be. So 56, 96. So that's going to be where it's going to be. And this is not going to be a speed label. It's going to be called turn rate label. Turn rate label is the new one, as we're making this up. And this is going to be turn rate, so turn Great, there we are. And that's the next one. Next one we're going to go into is step delay label. Step delay label. So again, I'm just going to duplicate this one, duplicate. We're going to make this step delay label happen over here. And then the values are 56 and 148 for these two. 148, which is going to put this in the right place. And this will be called step delay. There we go. Quick iteration. And then we're going to add some sliders in there. So that's the next one. So the sliders are interesting. I'll talk about these in a second. So I take a slider and we'll drag it in. But it's pretty small to see. You notice the slider is like really thin and everything else. So I've modified it a little bit. This one is going to be called the speed slider. And when we make one, we'll duplicate it for the others. So here's speed slider. Speed slider is going to be a variable. So we're going to click onto that variable part right here. And then what we want is the hovered thumb image as well as the normal thumb image should have a different size. Okay? So that's what we're going to do. So I'm going to go with the values that you see here. So definitely a Z order of 2. That's important. So that's when it's going to hover over. And then image size. So that's going to be over. So if you look where it's looking at, it's use normal thumb. And there's also hovered bar. There's different ones you can see here. So normal thumb image. So if I go to sorry, I just want to make sure I'm in the right spot. Alignment, appearance, style. Yeah, there it is, style. So it is here. And if I open this up here, you can see that there is a normal thumb image. And right now it's set, the image size is set to 8 and 14. I want it to be 16 and 28, so bigger. So 16 and 28. So it's a bigger thumb image. And then the bar thickness should be 5. Let's make that bar nice and thick as an example. I also want to do the same thing for the hover. That's the normal thumb image. So if I hover over it, also I want to make that the same number. So please make sure that the image size for the hover is also 16 and 40 and 28. Okay, so whether you're hovering over it with your mouse or whether you're normally over it, it's 16 and 28. The bar length, this is important, 285, 44. So that's where it's going to be, 285, 44, and then it's going to be 255 and 30. So 255, 30. So now that we have one bar, it looks like this. Notice that the bar is on the left. To change this, that's the value that the default bar has. So if I click onto this, you can see that the step size is 0.1. We can change this if you want to make it nicer. Right now, I've chosen not to make this different, but if I want to, the min value and the max value and then the current value. So I want to make the current value 0.5, so halfway through, just as a demo. So the bar looks like this by default. Okay. So now that I have the speed slider, I can duplicate it, and now I can add in the turn rate slider. So turn rate slider, just rename it turn rate slider, and then change its location, which is going to be at 285 and 100. 285 and 100. And I can duplicate it one more time. And now it's going to be at the step delay slider, which is going to be at 285 and 152. 285 and 152. There we go. And you can see now that there's 3 sliders, one for each of the different things I want to control. Now what we need is some values. These are also going to be variables, but I want to copy one of the texts already. We have speed text, which is this one. So I'm going to duplicate that one, duplicate it, because it has our style and everything we want, right? I want to change the name of this to speed value. There we are, so speed value. It's going to be a variable right here, and it needs to have certain values. So 545, 44, 115. 545, 44, 115. And it needs to be 40, size is 40 instead of 30, there we go. And what I also want with this one is that it's left aligned, not right aligned. So one was right aligned, the other one's left aligned. That's the only difference with this one. It's not going to say speed, it's actually going to be a value like 400. So I like to test it out with like the value that it's going to look like. So let's say 400.0 is not a bad way of looking. And that is your speed value. Now that we have that set up, let's duplicate that again, duplicate that. And now that we have that value, I'm just going to make that the turn rate value. Again, we're going to do the same thing over and over again. Turn rate value, there we go. And now we're just going to modify the location of it, which is 545 and 92. 545, 92, There we go. So it's in the right spot. And then the last one is this step delay value. Step delay value. So again, I'm just going to duplicate this one, and then step delay value is going to be what this is going to be called. And then what I want to do is I want to put it at 545 and 148. 545, 148. And then once I've done that, I'm going to change the value so it looks like, what, 0.25, because the step delay is going to be low. It's not going to be as big as this. Even the turn rate, like realistically, I've set it 400. That's like 400 degrees. That doesn't make sense. So let's make it so that it's more normal. Like, you know, your turn rate should be something like, you know, 45 degrees. But even if you had a larger value, let's make it so it's 180 degrees. So that's what it should look like. So it's like more reasonable, right? So we're testing out the label, so it looks something like this. Compile and save. So that's the first part, and that's your basic controls. We also want to add in a button. Let's test out seek. So I'm going to add in a seek button. So I'm going to grab a button, put it down here somewhere, and we'll call this the seek button. Seek button. It's definitely going to be a variable type, so we can modify it. It's going to be 2 from a Z order perspective, and the location is going to be 62,348. 62, almost very close, 62,348. And the size is going to be 145 and 46. So 145, 46, that's the size. But the button doesn't have a text value. You have to add the text value on top of this. So I'm going to take a text value and just drag and drop it onto the button, which makes it a child of the seek button. And this text value that I'm going to use is going to be called seek text. And that's what it's going to be. This is this value right here, seek text. Okay? And it's going to say seek. So that's what it's going to say. It's going to say seek. And it's going to be, instead of being white as a brush color, let's make it black. So we're just going to make these 0, 0, 0. And that way you can see that it's a seek button. So that is your seek button, my friends. Okay? And that is your first iteration. This is the first iteration of your user interface that we're going to use. Compile and save. Are you with me? So again, what I'm doing here more than anything else is when I'm thinking about these kinds of things, speed, turn rate, step delay, and seek, right, is the stuff that's going to allow us to control our AI agent so we can test out different things. And think about what I'm doing. I'm actually trying to find, the reason why I'm doing this, I'm trying to find the optimal turn rate for our grid. We don't know what that is. Is it 45? Is it 60? Is it 90? And what about the speed? Is it 50, 100, 200? What is it? We don't know. And so we're going to test it out with this thing, and that's what it's for, okay, more than anything else. All right, so now that we have this, well, the next thing is we need some UI logic, and we can go back to the grid character for this. So I need 3 little variables: max speed, max rotation rate, and max step delay. We'll take a short break soon. So we can save this, save all. We haven't tested it yet, but we're going to test it. Back to my character. So under blueprints, I'm going to go to BP underscore grid character. Now, there's a lot of stuff going on here. Let's organize some of these functions. I don't like the way these functions are. So zoom, ortho, camera, this is a UI function. So I'm going to click onto it, and on the right where it says category, let's change this to UI functions, right? Initialize grid, that's a grid function. So that's a UI in some ways as well. But there's going to be other stuff in here for this stuff. For example, the set pawn location and some of this stuff is going to be part of steering behavior. So for example, seek would be a steering behavior, and so would flee. So let's add that into steering behaviors. Steering behaviors. Right? So I'll do the same thing with flee. We know that one is also part of steering behaviors, right? And then we can think about other ones like move to target. That's definitely related to steering behavior. So I'm going to put that there. Toggle behavior. That's definitely going to be part of steering behaviors. Rotate towards. That's definitely going to be part of steering behaviors, right? Calculate angle to direction. That's going to be part of steering behaviors, right? Set pawn location, update grid location. That may be part of a different thing. So we'll kind of come back to that. But I'm actually adding in max speed, max rotation rate, and max step delay. And those are variables that are down here. So we have grid properties, and grid properties include the grid controller and all that stuff. So we want to have other things in here, for my, rotation rate and all that kind of stuff. Let's add those in. So I want 3 things: max speed, So we'll say max, can't see this thing, max speed. Okay, that's max speed. And this is going to be of type float. I want another one which is going to be called max rotation rate, max rotation rate. And we also need max step delay. And this is all setting up our interface, max step delay. And let's compile and save these, and let's assign values for all these things. So max speed, right? Again, I recommend a value of 400. So that's going to be what max speed is going to be. Max speed. Max rotation rate is not going to be more than 180, right? That's even a lot. And max step delay is not going to be more than 1. All right, so that's going to be those values. All these three things, max speed, max rotation rate, and max step delay, all those things are part of my user interface. So that's what's going to affect my grid and my movement and all that stuff. And again, I'm not sure where I'm going to put those in, but they're not going to be here later on. Now that I have those things, I want to create 3 little functions. Actually, there's going to be 6 functions. I'm going to make 3 getters and 3 setters inside of my, my character grid. Okay, so one of them is going to be get speed percentage. Another one's going to be get rotation rate. Another one's going to be get step delay percentage. Okay, so let's start with get speed percentage. So that's the first one, get speed percentage. And I want you to think about these as computed properties in many ways, right? So let's add a new function. Oh, that was weird. Add a new function. And this is get speed percentage. And get speed percentage is going to use speed and max speed. So if I take speed and max speed, which is I just made, oops, so here's max speed, speed and max speed, and I want to divide speed by max speed, so divide this by these two, then I get a percent, right? That's what I get for these. And that's the computed part. And then what I want to do is I want to return that as a return node. So I can add a return node. Here's a way to do this quickly. And then the return node, if I just drag the result here into my return node, it adds in the right value. So this is my speed percentage, right? And then the value is going to be percent. Okay, there it is. And I also want to make this a pure function. So I don't want it to go through execution path. So compile and save. So that's my first one. Let's do the other 2. So again, I'm just going to go back, grab that name, copy it, go back to here, make a new function, and then paste it in. And then it's going to be the same thing. Rotation rate is going to be rotation rate divided by max rotation rate. All right, so I'm going to divide those 2 like so. Okay, there we go. Now, there could be a function that does all the same stuff because we're doing the exact same thing over and over again. We could call this something like get percentage. And then you could type in, you can pass in the 2 functions every single time. That's also something we could have done it that way. I'm not doing it that way. So add return node. I'm just telling you that there's many ways to do the same things, and I just chose to do it this way because this is what speaks to me. And they're small little functions that we're going to use, and so we can call them, and they're not that complex. Again, add new function. The function name is going to be get step delay percentage, and that's what that is. And again, we get the step delay divided by the max step delay, and you can see that that is pretty straightforward, right? So add return node, and we're going to kind of drag this in. We'll call this percent. And these are our getters. And so what happens is we're using them as getters, get step delay, get whatever, but they're actually not getting an actual value. They're getting a computed value. That's why they're called computed properties. And that would be, if I just did the getters, it'd be read-only computer properties. But of course, we're going to make the setters now. So now that we have the getters, make sure, by the way, get speed percentage is pure, get rotation percentage is pure, get delay, step delay percentage, that's also pure functions for all of them. Compile and save. So now what we want is we want to do the opposite, which is the setters. So set speed percentage. So this is different. So I want to add new function. So again, set speed percentage where we get a percent. So percent is inbound this time. Here's my percent. That's what comes in. It's going to be of type float, right? And then we don't have a return node. We have the max speed multiplied by the percent. So we say percent multiplied by max speed. There it is, right? And again, I could have not drawn this line, but it's so small. And then what I want to do is set speed to this, which is what it's going to be. So this little calculation is something that we're going to do. And again, we don't want to mark this as pure because it's actually doing a calculation, right? So that's why we don't mark it as pure. So compile and save. Let's do the next ones. So add a new function. And this is set rotation rate percentage. And again, we get a percent in. And it's a float type. And we want to multiply it by a max rotation rate. So max rotation rate, multiply. And then what we're going to get is we're going to set the rotation rate to this. And that is the function. Compile and save. And those two, one more, new function, and we got set step delay percentage. And then we add in a percent value. And then we're going to do the same thing, step delay, max step delay, which is this one. And we take the percent multiplied by the max step delay to get the step delay. So why? Why do we do it this way? It gives us control, and it makes it so that I don't have to do those calculations out in the wild up here. I don't like doing it on the event graph. I like squirreling them away. Also, right now, if I want to test individual things, I can test individual pieces to it. Whereas if I don't do this, it's less testable. So I'm always trying to think about compartmentalizing in functions. Now, these functions are all UI related, like step delay and all this kind of stuff. So I want to make UI functions. So let's do that. So step delay would be a UI variable, and all these ones would be UI functions. So these 6 functions here are UI functions. So I'm going to say UI functions. That's what they are. So UI functions. That's this one. That's this one. And so on. Not that one. So I'm just organizing as I go. Because we were using these just for those. So because these are all UI functions, we can kind of close those off. So these are all grid functions. Anything like, get grid from world location, update the pawn, update grid location. These are grid functions. So that's where they belong. So I'm going to say these are grid functions. And so clear grid rotation, that's a grid function. And then that's another grid function. Again, I'm just organizing. And you should do this too, because as we go, we want to make sure that it's more user-friendly, because at the end of the day, there's going to be a lot of functions and variables, and it's a pain in the ass. So again, rotation rate, all this stuff. Realistically, that's all part of steering behaviors. But is timer active? Like the timer and all that stuff, speed, timer, and rotation rate, and step delay. Those things, these things are actually not user interface items. These things are related to the steering behaviors. So I'm going to make these as part of the steering behaviors. So instead of functions, we're just going to call these steering properties, right? So rotation rate, speed, right? Step delay, and is timer active. That's all part of steering properties. But max speed, max rotation rate, max step delay, those are all really UI properties, because that's all we need them for. So these are UI properties, and we're going to have other ones in here as well. So UI properties. And we're going to leave start pawn and goal pawn in the wild. Again, these are just ways I've organized them. Hopefully you're going to think about organizing your character a little bit differently, make it a little bit nicer so it's easier for you to look at when there's a lot of functions and properties. You don't want it to be like massive list. It's too long, it's too ugly. All right, so now that we've got those two things, then I can go back to my WBP SB overlay and go to the graph and start adding more functionality to the graph. So I want to do that. Back to the WP SB overlay, go to the graph node, and I'm going to just get rid of all this for now. There's an event called event construct, so that's the one I want. I just deleted it. Event construct. The construct event is like when the thing that is being created. And what I want to do here is I want to get actor of class, and I'm going to zoom in here so you can see it, the BP grid character. So I want to get a reference to that. So the first thing I'm going to do is I need a sequence node. So sequence node. And I like using sequence nodes. I know some people are like, they hate them because they just make these things happen. But I think they're more organized for me. So get actor of class is what I want to do here. Get actor of class, not actors, just actor. And this one's going to be the grid character. So BP underscore grid character. There it is. And then what I want to do is I want to promote this grid character as a kind of a variable. So promote to variable, and we'll call this grid character. So we're going to use this in a bit. And I do this upon construct. So the construct, I get the grid character. And then I want to get actor of class start pawn. So I want to do the same thing. So get actor of class. But instead of getting the grid character, I want to get BP underscore start pawn. And I want to promote that to a variable, which we'll call start pawn. So I have access to my start pawn and my grid character now. And that line right there is get references to grid character and start pawn. So get references to grid character and start pawn. Okay, so here, I'm just going to go here and mark it as black. That's why I like the color. You might like other colors. That's fine. Hopefully you do. Add other colors. And then the second sequence node is going to be this part, which is I want to get the grid character and get the speed percentage. Now I have that, and that's why I just set up this entire time. So get grid character, and then get speed percentage. This is like I'm getting a computed property. And then what I want to do is I want to get the speed slider and set the value for this. So speed slider, here it is, right? And then set value instead of set text, because sliders have values, not text. So that's going to go here. And what I want to do is I want to take this speed percentage and like literally plug it into the value like this. And this is ready to go. That's why I made those little functions, those get and set values. And this is basically setting the set value of speed slider, which is what this is. So set value of speed slider. And this is doing it one time. This setting the value of speed slider is happening when I pawn construction. So it's going to give me the right value, whatever I set the value to for those, for the value of what I have. So this is what I'm doing. So this is going to set it up or show it for the first time. That's what this is doing. I want to do the same thing for turn rate slider. So get grid character again. And then I want to get turn rate, sorry, get rotation rate percentage is what I called it, I believe. And then I want to get the rotation slider, which is the turn rate slider, this one. And I want to set value to this slider, which is going to be this percentage. Okay, because again, I'm using percentage for this, and that's pretty cool. And then I'm going to grab this and connect it to this. So that is this part, and this one is, here, let's put a little notch in there. And this is going to be set the value of the turn rate slider. So set value of turn rate slider for the first time. That's what this does. Okay, and then finally I'm going to get the grid character, and I want to get the step delay percentage. Get step delay percentage. And then I want to get the step delay slider. Here it is, get step delay slider. and then set value for this one. And then I'm going to kind of pump in this thing and connect it up to that execution pin. And then what we have is I want to set the value of step delay slider. So set value of step delay slider. There we go. And then let's change the color of that to black, add a reroute pin, and we're good to go. So that is right there, the first part of our event construct. We're not done yet. Compile and save. What I want to do now is after I've got that, then I want to start using the, I want to create 3 functions: set speed value, set turn rate, and set step delay value inside of this, of the widget blueprint itself, right? So now, again, you might think, well, like, dude, you're doing setters inside of my widget blueprint as well as, yes, I am. Yeah, it's more organized this way. So set speed value is the first one. I'm going to go into functions for my widget blueprint and set the speed value. The speed value is going to get the grid character. So this is the grid character. I need that one. And then once the grid character, I want to get speed. So get speed, this one, get speed. And then what I want to do is I want to get the speed value. This is the actual value here. So this is the thing that I'm setting up on for the text. And I want to set text. So set text is going to set the value of the value text box, and I want to convert it. Now when I do this, I get this weird conversion node, which is this text to float, right, kind of thing. Of note is what it also gives you. If you open this one up, it gives you these other values. So here's what I want. I want the minimum fractional digits for speed to be 2, okay? I want the maximal fractional digits to be 2. And I want the maximal integral digits to be 4. I don't want to have more than 4 digits in my speed ever. Even 4 is too much. It might be 3, which is good enough, right? And that's it. That's what I want to do that for. Okay, so I want to connect these up, and that is my set speed value. Okay, compile and save. Set speed value, as an example, is a setter, so that's fine. I want to do the same thing for set turn rate value and set step delay value. So let's do that. So I want to grab some of this stuff. So I want to grab the grid character, and I want to grab this to text. I want to grab those 2 things. The stuff in the middle is different, but I want to make a brand new function. So new function, where I kind of grab those 2 values, and this one is going to be called set turn rate value. Set turn rate value. Here it is. And the set turn rate value is going to take the rotation rate from the grid character, get rotation rate, this one. And then the rotation rate is something that I'm going to convert. I'm going to use this conversion node here. Well, I already have the properties that I want. I've already set those up, so I don't have to do that again. And I want to get the rotation rate to turn rate value, this one. Get turn rate value, and then I want to set text on it, which is going to be this. So that's all I'm doing there, and then that's the next one. Oops, put that over here. And compile and save. I want to do the next one, grab this one and this one again, copy it, and I want to bring a new function, bring those in, because I'm going to use those again. And I know that the new function is going to be called set step delay value. So we're just going to rename that function to this, set step delay value, and then what I want to get is the step delay value. So step delay value, there it is. And I want to set text, and that's this. And then what I want to do is I want to get the step delay, this one, from my grid character, and plug that in, and plug this execution pin into the set text. And now we have the next one. Okay, compile and save. Again, you can make these prettier if you really want to. I'm just slapping them together to make sure that I have all that. So that is your step delay set values for the first time. So now I got to put those back inside of my constructor, my construct function. So this is my event construct. I want to call each of these things right in order so I can set the initial values in the user interface. This is what this does. So again, I add another pin here, and then I just call those 2 things. So set speed, set turn rate, and set step delay right here in a row. Otherwise, what I'd have to do is actually put this all out here, and that's ugly. This is a little nicer, and what this does is it allows me to do set at the initial speed value, turn rate value, and step delay value. This one I don't like, it's not named properly. I think I should call this turn rate. I don't know what I did that there, turn rate, is that turn, maybe yeah, I did it here, haha. In my PowerPoint, that's what it was, right? That's why I named it wrong there and it's named it wrong everywhere else. Okay, so that, now that I have that, then I want to listen for my on value changed event. So when my speed slider, when the user changed my speed sliders or any of my sliders, then I want to modify everything both on the user interface as well as the character's values here. So that's why I've done it this way. So again, the way on value change works is if I go to the slider, so if I go to the first speed slider, this one, and then on the bottom there's on value changed, I can click that. Let's click them all. So there's the first one. And if I go to the turn rate slider and I click that one again, and if I go to the step delay slider and I click that again, then I've got those three events. Those are the three events that I want to use. They're all similar, and I did this for a reason, because then I can just do grid character, which is this one. Here's grid character. And I know I'm going to copy that 3 times. There's grid character, grid character, grid character. Right? And these events are going to be activating the grid character. One is going to set the speed percentage, set speed percentage, right? Where the value of this one is going to change this. That's what's going to happen there. And I can pass that through there. And then what I want to do is I'm going to set the speed value here. So set speed value is what I have here. There we go. That's what I just wrote. And then the next one is set rotation rate percentage. Set rotation rate percentage. That's the function that we just wrote. And that one is going here. That value is going there. And then I'm going to set rotation rate value. There we go. And then finally, the grid character set step delay. Set step delay percentage, where I'm just going to grab that one. So I'm wiring up my user interface, and there, this is it. Okay, so that's how it's going to look. And there you have it. Those are the 3 events that I want. Each of these events is linked up now. Almost ready to take a break. Almost there. Finally, the button. I want to do the button too. So the button has, if I click on the seek button, here it is, and there is a on clicked event. Here's the on clicked event. Then I want to get the grid character. Again, here's my grid character. And what I want to do with it is I want to call the toggle behavior. So toggle behavior, and we're going to toggle seek, which is kind of the same thing that we've done, whether you're using the inputs from your user interface like this, or whether you're doing it from the character. It's the same thing. You're just using the same behavior, right? So I'm just calling the same function. So that's good. Let's try it out. So compile and save and test. So now if I press play, I'm going to get this little user interface on the left hand side. Take a look. Right? Here it is. And it's set to some values already. So it's set to like speed of 150, turn rate of 45, and step delay of 25. And if I modify these values here, like so, like let's say for example I want to increase the turn rate to 90, it's going to have an effect on the seek. So now what's going to happen is seek is going to be 90 degrees. It's going to create a different pattern when it moves around. It's actually not great pattern, right? And as I go lower, if I actively change the turn rate lower, you can see that the circles get wider and wider because it can't turn so fast. There's that larger circle. Take a look, right? You see now the circle, because I'm only 23 degrees maximum turn rate, it's going to take a long time for me to get to this. Okay, that's how it works. Step delay, if I increase the step delay, it slows it down. Watch. So if I increase the step delay, then what it does is it slows it down. But I have to stop this and restart it. And then what happens is it becomes a lot slower. And the reason why I have to stop it and restart is because step delay is part of my timer. And here I'm kind of pausing and restarting my timer function. And that's why step delay is not interactive the same way. Okay? Speed, on the other hand, if I stop this, let's go back to 0.25, something like that, 0.25. And if I increase my speed, so if I go to something like 200, right, and if I click seek, now you can see that at 200, the behavior also is different because every step is 200 units as opposed to, and it's also snapping to grid at the same time, right? The bigger the speed that I make, the wider the circle, the much bigger the circle. Take a look how big the circle is now, right? And same thing, if I increase my turn rate, right, the smaller the circle, okay, because I make the circle a lot better, right? So if I decrease my turn rate, as I go smaller, the circle gets much wider, right? Because it's more difficult for my agent to turn. Okay, that's what happens. And that is the value of this little slider. And for you, the idea is here, you're testing your AI agent and how you want it to maneuver. And here you're controlling the details of how this happens. And so you've got to come up with these optimum values. Clearly 270 and 18 degrees, probably not good, right? But it's, you don't want to make it realistic. So how realistic you want the thing to turn is what you're doing here. Let's stop this. So that is the first iteration. And before we take a break, I want to add in the other button. Flee is what I want to add in. So let's do that. So back to this part, I want to go to my designer and I want to add in a button, flee. So let's add that in. Let's duplicate this, duplicate. And we'll call this the flee button. There it is. And now that we have the flee button, we can move it in place, 232 and 348, 232 and 348. Again, I'm doing this so that way you can visualize. This is the flee text, and it should say flee. Now my button looks like it's proper, but there's no control over it. How do I control it? Well, that's easy. I can just go and add another click event in the graph right here. So I can look at the flee button, go down to the on-clicked event. Here it is. And then I'm going to do the exact copy here, copy this. But the difference between now and the behavior is one is going to say seek, and the other one is going to say flee. And once I have those two things in place, then I can test out flee as well as seek. So the way this works is if I press my my start pawn there, and if I click the flee button, it's going to flee away. All right. If I click the seek button, then I want it to seek back to my my thing. I can stop it and start it, and I can press seek, right? And you can see that it's wigging out, right? And it's wigging out because, it's got some issues right now. Let's take a look at that. I made it go off grid because of what I did. So let me show you what I did. And this is a bug that we have actually in our thing. So again, if I go to this and I click flee, and if I click stop, and then if I click seek, then it should go back, and it does, right? But once it goes to the border and comes back, once it gets to the border, it's stuck forever. Like it'll wig out, right? So there's some things we can fix in that, and you should fix that problem because it's a bug. All right, there we go. All right, this is great. File, save all. Let's put this up on DevOps because we have now our user interface and we also have our flee behavior. So git add dot, git commit -m, we'll say added UI controls and flee. There we go. All right, so we're sitting at 1:28. Let's take a 10-minute break, maybe some coffee and that kind of stuff for people that are here, and maybe some bathroom break for people that are not here. And then when we come back, we'll continue with the next part, which is arrive.